everyone, welcome back to another Weeks Bay Tea Time Talk. First of all, thank you guys so much for joining us. And today we are here with Scott Phipps, our research coordinator at Weeks Bay. And we are out on the water in our pontoon boat. And Scott's going to talk to us a little bit about some of the research he does here. And I think, Scott, let's start out with just some description of what your position is here at the reserve.
Well, as the research coordinator, I deal with whatever kind of research that other people are coming in and doing. We also have research projects from time to time that we do ourselves. My interests and inclinations are in water quality and algae, so that's kind of what I like to do, but I get involved with a lot of other kinds of research and also run the monitoring program here at Weeks Bay. We call it the system-wide monitoring program because all of the NERs all across the nation do the same thing, and we all monitor the same things. And so we monitor water quality and weather and the state of the marsh.
So today it looks like we're in a canal, and if you can see behind Scott, that's US Highway 98, which is running over the Fish River Bridge, which goes into Weeks Bay. And Scott, we pulled up to this dock here that it looks like it has a tube going into the water and then a big box back there with solar panels on it, and I see on the box it has like a NOAA sticker on it, so it makes me think that it's probably pretty important. What is this contraption that's behind us?
Yeah, so that's a NOAA tide station, and it is through the NOAA's, we call it NLON, it's National Water Level Observation Network, and it's part of that, and it's in the co-op system, and so they have this tide station sitting here. So the big box is where the data logger and the batteries, and then there's solar panels, and then that thing that looks like a top hat on its side is actually an antenna facing a satellite. The tube and the thing on top of it, that's the actual working end of the tide station. The thing that's sitting on top is a sensor. It's an acoustic sensor. And then the tube is a stilling tube, goes way down into the water, and that kind of helps to prevent the measurements from being disrupted by splashing around. But anyway, every 6 minutes, that sensor takes a reading with its acoustic sensor as to the distance between that sensor and the water. And the sensor has been surveyed in. We know exactly to the millimeter of where that sensor is according to elevation, and we come back and check it at least yearly to make sure that it hasn't moved. It takes those data every 6 minutes, and through that data logger and that top hat, it transmits it to a satellite, and it goes online, and so we can log in online and see those data as they're occurring. And if you go to that weather station, what you'll see is and it's 857-2828 is the number of and we'll put all this information available so you can find the website. Okay. But if you go to that website, what you'll see is the main thing is you'll see a chart. It'll have a blue line that is the predicted tides, and they produce that predicted tide using the data that this station has created it's been in operation for 13 years. And solar and lunar calendars, and also they add in data from other stations in the area that have been in existence for a long time, like the one over at Mobile has been taking tidal data for over 100 years. So with all of that data, they can then predict what's going to happen tide-wise, and then there's a red line on there that's actually showing what actually is taking place.
So in a given day, then, I guess for like Weeks Bay, what would you say an average tidal range is?
So at Weeks Bay, from high to low, on average, we have like 1.6 feet.
Wow, that's not a lot.
No, it's not a lot. But along the northern Gulf Coast, that's a typical tidal range. We don't have high tides here.
What type of tides do we have in the Gulf of Mexico? Like, do we have 2 high tides, 1 high tide, 1 low tide? What type of tidal regime do we see?
So they call it a diurnal tide. We have a high tide and a low tide once in the day. So like if you're on the Atlantic coast, you'll have 2 highs and 2 lows. We only have 1 high and 1 low on average. Now, during a neap tide, we might have more than one. Our tidal cycle here is about 24 hours and 50 minutes from high to high. And that's, so basically 1 high and 1 low a day, and they're usually about 1.5 feet apart. And
I always found that really interesting because, like you said, on the east, the Atlantic coast and the Pacific coast, they have the 2 highs and 2 lows a day. But a lot of that depends on the shape of the Gulf of Mexico itself.
That's right.
That allows us to only have that 1 high and that 1 low. And you said about 1.6 feet in a tidal difference, which I said didn't seem like a lot, but I feel like at times I've seen like much higher tides than that 1.6 feet. So what's happening during those times?
So we have a couple things going on here. So as any of you who live around here know, Weeks Bay is very shallow. And so when we have a strong southwest wind, which we often do in the summer, it pushes water up into the bay and it raises the water level here in the bay. And it can do that much higher than the tidal, the tidal cycle. So, and vice versa, if we have a strong north wind, the opposite occurs and it gets really shallow in the bay. And that often occurs in the wintertime. We also have a change in, so if we have a storm in the Gulf or something, that can actually cause a tidal surge from the wind and the low pressure over us. Then the water builds up in an area like this. Rainfall. Here in the Mobile area, we have an average of 60 inches a year in rainfall. And anybody who's lived around here knows that there's several times a year when we might have 2 to 3 to 4 inches in one day. So there's a lot of water coming down these rivers. If that water's coming down the river as the tide is coming up the bay, it just builds a big pile of water in the middle, and we record that. So we can have times when the water gets up in the parking lot and it's several feet above mean high. Mm-hmm. One of the things that you'll see in that tide chart, there will be when it's telling you how high the tide is, there's a 0, and then like today, 1.5 feet above 0 at high tide, whatever. That 0 is mean low water. What that means is if we look at the tide cycle, we'll see spring tides and neap tides. Spring tides are when the moon and the sun are lined up and we have really high highs and low lows, and they're in time and very even. And in between, when the sun and the moon are not in alignment, they get kind of at right angles when the moon is, say, a quarter moon. Mm-hmm. And at that time, everything kind of gets jumbled up and out of time, and so the tides will be going kind of bouncing up and down, but they're not moving very much, and we call that a neap tide. So we don't average, to get mean low water, we don't average those neaps in there. We just average the spring tides. We look at the lowest average spring tides, and that's our line for 0. And so all those numbers, if it says it's 3 foot or 4 foot, that means it's 4 foot above that mean low water.
Wow, Scott. Well, I really appreciate you taking the time out of your busy schedule to talk to us about these tide stations we have set up. I hope if any of you have questions, you feel comfortable just dropping them in the comments or reaching out to us at Weeks Bay. We always love to hear your questions, and we're always here to hopefully answer them and really keep you informed about what we do here and any concerns you might have at home. And with that, I hope you enjoyed a nice cool beverage and today's Tea Time Talk with a Scientist.
Thank you.